This section is Making Sense of Statistics, Section 14, the Coefficient of Determination. So a coefficient of determination is useful when interpreting a Pearson's R. Now the symbol for the coefficient of determination is an R squared. So what we are going to do when we compute it is simply we're squaring R. So if you recall back on how you square R, you multiply R times R and you get your R squared. So if R is 0.60, then R squared is equal to 0.60 times 0.60, which equals 0.36. Well, let's look at our example 1 in our text. The computation is very simple of R squared. Sometimes an R squared, the meaning is difficult to grasp. So let's look at the scores in example 1. So we have 5 young children who took an oral vocabulary test before they begin learning how to read. So after 6 months of instruction, they then took a reading test. So as you can see, there is a positive relationship where you might be able to find those who scored low on vocabulary, such as John, also scored low on reading, and those who scored high on vocabulary, such as Diana, also scored high on reading. So what we can say is we can say that the vocabulary scores are predictive of the subsequent reading scores. So we do have positive relationships both on John and on Diana. We can say that the vocabulary scores are predictive of the subsequent reading scores, but then the question is, how predictive? So now let's say that the Pearson R on the previous example, the value of Pearson R for the relationship between the two sets of scores in example 1 is a 0.90. And so now I know a lot of people then say, well, how do we compute the Pearson R? Well, the computational procedures for obtaining the value of the Pearson R are beyond the scope of this book and thus the scope of this class. So that's not something, if we look at what is the Pearson R, I will not ask you to calculate a Pearson R. However, one thing that we need to know is that the Pearson R is a 0.90, and what we can say is that the oral vocabulary scores are highly predictive of reading scores, but we actually can be. So what we can say is there is a variance or differences in the scores on the reading test. So when interpreting the Pearson R, one of the important questions is what percentage of the variance on one variable is accounted for by the variance on the other. So if we are trying to predict reading scores from oral vocabulary scores, the question might be better phrased as what percentage of the variance in reading scores is predicted by the variance in the vocabulary scores. That actually is easy then. So we can actually answer this question. It's easily determined. We simply square R and multiply it by 100. So For the scores in example 1, we have r is equal to 0.9. So then we can say 0.90 times 0.90 equals 0.81, and 0.81 times 100 is equal to 81 or 81%. So we have just answered the above question of what percentage of the variance in reading scores is predicted by the variance in the oral vocabulary score. So we've just answered that with 81% of the variance on one variable is predicted by the variance on the other variable. Section 14 on making sense of statistics, and we are completing a coefficient of determination.